Good morning. Today we'll be doing time-based key value store. In this particular problem, we are going to create a time-based key value store where we are given a key and we have values. And for the value, we are looking for the most recent item. So suppose that we put 1 and into our time map. Let's say it's called, our time map is currently, its key is food, and we have bar with a value 1 in it. And so at time 1 we have food, and at time we're looking for time 3. However, time 3 doesn't exist, and we return the most recent one, which is time 1. So we return bar, as you can see here. And then now suppose we insert bar 2 into our items, and this is 4. And looking for 4, we can return bar 2. Looking for 5, return bar 2. So in this sense, we're gonna, if we look at a get bar foo at 3, then we return 1. We insert so set foo, set bar a 1. Oh, sorry, it's foo bar and then 1. Then get 1 would return 3. 1 would return 1, and set 4. We would return, if we tried to get 4, we would get bar 2, and if we tried to get 5, we would get bar 2. If we again tried for anything lower than 4, we would get bar from that result. So as you can see here, one of the ways that we can do this is to just, run across the entirety of all the items that we've stored and find the correct timestamp. I guess the latest timestamp possible. But that will take O of n time based on the number of items we store per that key. A way to speed that up is to use binary search, because on both, this is in chronological order. If it's in chronological order, that means binary search is available to us, and we can, store that. So let's check it out. So self.hashmap is equal to a default dictionary of type list, because we have to store a bunch of keys and values, and the key is foo, and the values are going to be like the phrase and the timestamp. So when we're setting self.hashmap dot append, what we're going to append is a key. Well, not that. This particular key. And we're going to append the value and the timestamp. And that's it for here. With that, we can do the get function. So the get function requires us to have a left and right pointer. So let's get through that. So left, let's get the list first. So our should we call it list? Maybe. I think we'll name it now, and then we'll deal with it later. So we get all the items from this particular list here. Then we create the left and right pointer, which is equal to 0, and the length of list -1. Hopefully this doesn't cause us problems. And we just need the results, which is an empty string right now. So while left is less than or equal to right, we can get a mid, mid is equal to, sorry, left plus right divided by 2. If list mid is less than our, or equal to our timestamp that we're looking for, then that means we can do L plus equals 1, because suppose it's less than or equal to a timestamp. That means we have found something that we can return, but it is not exactly that thing yet. So let me show you. Suppose we're looking for something bigger, right? I'm really enjoying these extra comments here. So 4 bar 5, 13, 14, 15. So 2 and 3 and 4. Suppose we have 4 items, right? We have a left and right pointer. That's a lot of spaces. Let's try tabbing. Okay, so tab, tab, tab. Now we're at 2. Suppose we're looking for 4. Well, we didn't find it here. R minus equals 1. And results is equal to our list of mid. Right. One thing about list mid is that we need to, there are 2 values in list mid, I forgot. So the 2 values are the value and our time equals list mid, and we have timestamp. I think I like the word target more to make this more logical to us. So let's change that time equals timestamp, and this should equal to our timestamp. And we're going to do target here. Result is equal to our value. All right, I think that should be good. And this should be timestamp. I think should we be more clear? Well, if it's not less than or equal to, it has to be greater than our target. So right minus left, I think that's clear enough. So right. So if it is greater than our medium, then we do R minus equals 1, equals minus equals mid plus 1 and mid minus 1. Sorry, so too early in the morning, we're making a lot of mistakes. But we're catching all of them, which is also good. So now we have bar is equal to bar, our result is still equal to blank at this point, because we have found nothing that is equal to a target, which is equal to a 4. So now 0 and 1 is going to get us to 0. So we found our first result. It is 1. It is less than our timestamp. Our target. Our timestamp is less than our target. So we're going to set that at bar. Result is going to turn to equal bar, and we'll move left up 1 because we are within bounds. And with that, we set our item to bar 2 because it's equal to, and we move left, and now we are done with our cycle. A binary search, because that way we have gone through all the items already in log of n time. So with that, we'll return our results. Oh, and there's a lot of code here that is not code. I mean, a lot of words here that are not code. It's just for C. So with that, I believe we have a pretty nice solution, and we have solved this particular problem. And if you enjoyed this video, like and subscribe. If you want more videos, check the link in the description below. And if you have any questions, please comment. Thank you very much, and I'll see you in the next one.